Okay, so on the number 6 on this one, we're going to go ahead and we actually inputted our parent function information yesterday. So that was from the actual original parent function, which I don't have the copy of in front of me, I don't think. Oh, I am just joking. I do have the copy of that. So what we had yesterday, our parent function information. So the -2, -1, 0, 1, 2. We are going to take those inputs and outputs, and we're going to put them in right here on number 6 into our parent function area. I would not encourage you to use pen like I just did. Let me get my pencil. Okay, and so let me zoom out here so we can see that. We're going to go ahead and go with our -2, our -1, our 0, our 1, and our 2. Our outputs then are 2, 1, 0, 1, and 2. Now, I know that you can always just try using the parent function stuff there and seeing if it works based on the transformations you're doing. However, I know it should work because I'm not multiplying. I won't be multiplying anything by a fraction. In other words, b is a fraction, but the reciprocal of that is not, and that's what we'd multiply by. And a is not a fraction. Okay? So looking at those, I want you to kind of discuss what things would affect your ins and what things would affect your outs, which would affect your x values from the equation or the function, and which would affect your y values from the function or your g values. Okay, that was a lively discussion. Okay, wow. Do you guys like the people you sit by? You can choose where to sit. Okay, like maybe let's try to discuss those things real quick. Okay. Wrap up discussion. Hopefully it was just a real quick. Okay, which things from our function affect our inputs or our x values? Any ideas? Okay, the 1/5, the 1, and there's another thing? The negative. Okay, so those three things, everything inside the absolute value symbols here will affect our x's, our inputs. Everything outside, so 3 and -9, those are going to affect our outputs. So I guess rather than x's, maybe I say n's. Okay, these are going to affect our n's. Now remember, we're doing our table like this to make it so you can't just throw that into like Desmos and copy a table down and then copy a graph and be done. Practice your transformations. Yeah, well, that's what we're going to do as we put them in here. Okay, the 1/5 does not change to a 5 in the function. In the function, it's still a 1/5. So for instance, if I were to just create like a normal table of values, an XY table, and I start putting in values, say like, I don't know, 5, I would actually input 5 here. I'd do 5 plus 1, which is 6, and I'd multiply by 1/5, -1/5. This doesn't change to a 5. This is a 1/5. It's just when we look at it graphically, it affects our input by a factor of 5. It looks like it stretches it by a factor of 5. So let's start with that. Okay, our first thing that we do, order matters. Inside here, we're going to start with the multiplication. If it's in true vertex form, which is this form right here, where you have b times x minus h, you have 1x, right? Which we have right here. We have that 1x, so we factored in here. Okay, it's in true vertex form. When I look at this, I can say, well, I have 5, I'm multiplying by 1/5. That is a horizontal. It's happening inside. It is a stretch. Okay, it's a horizontal stretch. Remember, when we're multiplying by our b term, horizontal stretch if b is between 0 and 1. Okay, and when it's a stretch by the reciprocal of that. So the reciprocal of 1/5 is 5. So BAFO 5. So that's what you're asking there. Can we multiply it by 5? Well, your inputs would end up multiplying by 5 graphically, not in an actual table of values. In a table of values, like if you're building a normal table of values, you just would put 5 in here and do the math. Okay, or you'd put 1 in here and do the math. Okay, this will help us transformation-wise. So in this case, this does mean I multiply each of these by 5. So the point that was at 0, 0 is now at, well, that's 0 times 0, or 0 times 5 is still 0. Yeah, that would be negative 10. Negative 2 times 5, negative 1 times 5, 1 times 5, and 2 times 5. Okay, so don't confuse this, the way we're doing this table, with what you would do in a normal table of values. Normal table of values is just input-output feature. This is for us to look at transformation-wise. So really, if we wanted to, and I don't want you to do this, just paying attention here, you have your parent function that originally is this right here. By doing your table this way, what's happened is you've taken each one of those points that were there, those little dots, and now you went and did a horizontal stretch by a factor of 5. So if you just stopped right there, this would actually be where you just had g of x equals the absolute value of 1/5 x. That's what you've done just with this. That, if we just graph that function, don't graph it, but if we did that, then you would have negative 10, positive 2. That would, you go to negative 10, 2, that would be there. Negative 5, 1 would be there. 0, 0 would be there. So you would have stretched this like that. Notice my function has been stretched. Like if I were to sketch that, it's been, oops, that's ugly, man. It's been stretched vertically, or excuse me, horizontally. It's been pulled out. That's what that's done. But we're not doing that. Now, we could actually do that for every part, but that's not the point of it. The point is to actually get a final answer. And there's other ways, like you should be able to just look at this and know the vertex. What's my final vertex going to be? Not going to be 0, 0. What's HK? Yeah, negative 1, that's H, and K is negative 9. That's our vertex. Negative 1, negative 9. That's the actual end vertex. So our end vertex, when we're done with this, we better have a vertex at negative 1, negative 9, which is right there. That's our HK. That's what HK tells us. When we're looking at this, you may want to make a note of that. HK is our vertex. The vertex is HK. I mean, some people say, who cares? But, like that doesn't work with the letters. But, who cares? HK. All right? That's our vertex. Yeah, it is cool beans. Unless they've been heated up, then it's warm beans. Okay. What's the negative do? Good. It's a reflection over the... Yeah, it's y. It's horizontal reflection, right? So we go this way. Reflect this way, which just means you take each one of your values and change the sign. Okay? So this becomes positive 10. This becomes 5. Go ahead and change all those signs real quick. Okay, so now if we had this, we would be at negative 1/5 absolute value of x if we were to graph it. Right? So the first one would have got us to that part. This part gets us now there. And now we're going to do the last one dealing with the 1. The 1 is a good horizontal translation. Left 1. Okay, and so like if we're doing that, if we're going to the left, we're moving this way from here over, meaning we are subtracting 1. We're doing the opposite of what we actually see up here, which makes this 9, 4, -1, -6, and -11. Ooh, that's off my graph. Hey, but notice we're done with our horizontal and our vertex is at -1. That's good. That's where we identified it, right? We're golden there. And by the way, this now would look like this, where we actually have our -1/5 x plus our 1. We did this first, and then we moved that. Okay, we replaced x plus 1, so that's our absolute value. So we've dealt with just the input part. We still have to deal with the 3 and the -9. Okay, so this did that. The 3 and the -9 is over here. So we start with the multiplication. The 3, that's a vertical stretch, BAFO 3. Go ahead and do that to your outputs. Hopefully you got those. Go and tell your neighbor the last part. Nice work. I heard it there. Vertical translation down 9. So we're moving this down 9. That -9, which we actually do -9. What's 6 minus 9? Yeah, -3. This becomes -6, -9, -6, and -3. Hey, notice what our vertex is. The ends of our table, -1, -9. We don't use this, so we cross that out. But our order pair, -1, -9, there is our vertex. That's what we thought it would be. -1, -9, it's there. Okay, that's our HK value. We have our 4, -6. It's a -6 right there. We have our 9, -3. Oops, not -9, 9, -3. We have our -6, -6, -6. Should go in the right order. And -11, -3, which won't fit on our graph, but there it is. Okay. Any questions? I'm not going to graph them. I think you guys can plot the points. Hey, really quick, are we clear that that's not how you create a normal table of values? I want to make sure everyone understands the difference. Okay, so just bear with me just for a second. Okay, if I have this function, g of x equals 3 times -1/5 x plus 1 minus 9, and I'm doing a normal table of values, an x and like g of x, and I have an input output, this is my rule that drops in right here, my 3 times -1/5 x plus 1 minus 9. And I have, I don't know, one of my inputs is 0. That's when I actually input 0 for x. So I have my 3, absolute value, -1/5, 0 for x. So I replaced x with 0, plus 1, okay, and minus 9. And if I have 1, I put 1 in for x. So all the numbers stay the same. I just keep inputting for X. I could create a table like this. That's the normal way we create tables. You could go through that process. Yeah, Owen?
When you're filling out the table, would you actually solve?
Yeah, you do the math here. So negative 1/5 times 0 is 0, right? Oops, I forgot a parenthesis here. Okay, negative 1 0 plus 1 is 1 times negative 1/5 is negative 1/5. Absolute value of negative 1/5 is positive 1/5, right? Times 3 minus 9. Okay, so we'd end up going through that whole process and calculating what we have there. Like we actually do the math. Am I making sense there?
Yes.
Okay. All right. Good? Yeah. Okay. Very good. Any other questions? I don't want you to be confused with the tables. This is a very unique table meant for a specific reason. You can here in a minute, yeah. All right. Cool.